Okay, we're back here. So now so the energy before equals the energy after. What's the energy before? Well, it's got kinetic energy before, and it's got its gravitational potential energy before, and this is equal to the kinetic energy after plus the gravitational potential energy after final. All right. Well, let's put in the number. Let's just put in the equation. 1/2 mv. Now, did you notice in this problem that we didn't ask for weren't given the mass of the baseball? That's because the energy is conserved. Okay, energy is conserved here. There's no energy is conserved. Huge idea. Conservation of energy. Okay, the energy is conserved here. So 1/2 mv squared plus mg h naught is equal to 1/2 mv final squared plus mg h final. Let's cancel the masses. Notice we can cancel all masses in this. One reason is because energy is conserved and these two equal each other. If energy wasn't conserved, there'd be another dragging force or a frictional force over here we'd have to add that didn't have a mass to it. So we couldn't just cancel all masses. But now we can. We can just sit there, go right through here, and go bye Felicia, bye Felicia, bye Felicia, bye Felicia. And we wind up with 1/2 v naught squared plus, now what is the initial height? 0. The initial height is equal to 0. Plus 0 is equal to, what's the final velocity? Final velocity is equal to 0 plus g times the h final. So really on this side I've got v naught squared over 2, which was given, is equal to 9.8 times height final. So the final height, when I do my little algebra here, I'm going to divide by 9.8 and then put 9.8 over here in the denominator. I wind up, the formula actually for the final height, as long as forces are conserved, our energy is conserved, the equation for your final height in a simple problem like this is v naught squared over 2g. Okay, so I can do this. So I've got the final height is equal to 16 squared divided by 2g, and you know what that comes out to be? 13 meters. The same thing that we got before. This time we threw the ball, but in other words, this change in, and what if I just look at the energy of that baseball? Let's just look at the initial kinetic energy of the baseball. Would equal 1/2 times 0.145 kilograms. Did I ever tell you the mass of the baseball? No, 1.45. Oh, we did in the problem in the text. Times 16 squared. You know what that equals? It's amazing. That equals 18.6 joules. Just exactly what we got in the last problem. 18.6 joules. So there it is. I'm going to have to make that smaller, aren't I? It's a little bit smaller so I can squeeze it all in. All right, out here.